Number 6 reads, a coyote falls from rest from a height of 18 meters above the head of a terrestrial cuckoo bird, a bird also known as a roadrunner. If the bird's reaction time is 0.1 seconds, at what distance above its head must the bird spot the coyote if the bird is to escape? Alright, let's see if we can clarify that problem a bit with the animation. Let's see if this coyote has any luck. Now the bird escapes. Let's take a closer look at this problem. The bird must spot the coyote when it's about there. We're told at a time of 0.1 seconds, sooner than the coyote would hit the bird. The bird has a reaction time of 0.1 seconds. The problem is to find the height above the bird that the coyote is at that time. We're also told that the coyote falls from rest, a total distance of 18 meters above the bird. Let's give the coyote one more chance and see if he has any better luck. No luck that time either. Alright, give that problem a try. Here's a figure of our problem with some additional information that V0 is equal to 0, that coyote falls from rest. I've also claimed that at time t equals 0, the initial displacement is 0. The coyote falls 18 meters if it is to hit the bird, so I've labeled y minus 18 meters. It's downwards, hence the minus sign. The bird must spot the coyote at some height above its head at a time 1/10 of a second before it would hit the bird. The problem is to find out what this height is. One of the difficulties that students have with this problem is that if you examine your equations for free fall, you will not find an equation that will now enable you to directly solve this problem. We have to approach it in kind of a roundabout way. And the reasoning is this. If we could find the time that it takes the coyote to fall the full 18 meters, let's just call that time t. We could then subtract 1/10 of a second from it and find out how long it takes the coyote to fall a distance, let's call it y prime, to the point we're interested in. Let's say that time is some time t prime. So that will be our approach. I want to use our general expression for displacement. Y is equal to y0 plus v0t plus 1/2 gt squared, and substitute in for y minus 18 meters is equal to 0 for y0, 0 for v0, plus 1/2 minus 9.8 meters per second times t squared. And if we solve this for t squared, we get that t squared is equal to minus 18 meters divided by 1/2 of 9.8 is minus 4.9 meters per second, and that quantity gives us a value of 3.67 seconds squared. If I take the square root of that, we'll get that the time is 1.92 seconds. Now, t prime would be 1/10 of a second less than that, or simply 1.82 seconds. The next problem is to find y prime. And if we solve for y prime, we find that y prime is equal to 1/2 minus 9.8 meters per second times 1.82 seconds, that quantity squared. And if you evaluate that, you'll find that this is minus 16.2 meters. Now our height h is just the difference between these two values of y, this difference between 18 and 16.2, so that is simply 1.8 meters. Alright, that then is the height at which the bird must spot the coyote if it is to escape unharmed. Alright, that is our problem. Let us move on to our seventh and last problem.